السلام عليكم يا ساينتيفيكيون. ايبيزود جديده، انترفيو جديد مع ضيف جديد اوف كورس. دونك ان شاء الله وي ويل تراي باش نهضروا على ان انتريستينغ سبجيكت اللي بتاتر حكينا عليه من قبل مع صديق. سي فو رابيلي بيان، حكينا على الكوانتم فيزيكس شويه، الهيستوري تاعها حكينا في كونتكست هيستوريك، سينا نديفلوبيو لي زيدي هيستوريك كي اون فوندي هاد لا تيوري. مي اون غرو اليوم راح نديروا صوالح بشكل مختلف because الضيف تاع اليوم is somehow a specialist, I may say to some extent. So انا جامي عيط لها باسمه الكامل، بصح اليوم معنا رجيل ابو بكر الصديق. I hope قلتها مليح. دونك انا نعيط له توجور بيلو. داير دوك من بعد نسقسيوه علاش نعيطوا له بيلو. I never asked you that. دونك بيلو، مرحبا بك في ساينتيفيك هضره. تفضل.
Thank you, bro. Thank you. Like I am honored to be a guest here in your podcast, and I am looking forward into exchanging ideas with you, and hopefully get out with more ideas.
صح عليك. باينه اليوم نخلطوها بالايدياز شويه. We will twist our minds around things. Donc Bello, present yourself وقول لي specifically, essaye to elaborate why did you choose physics?
Well, like to present myself, I will go traditional style. I am Rajil Abu Bakr Siddiq. People know me as Bellou, like you mentioned. Currently, I am a master's student in theoretical physics at the University of Science and Technology, Houari Boumediene. If I can describe myself in one sentence, it would be the jack of all trades and the master of none. I find knowledge very interesting, and I try to know as much subjects as I can.
Mm-hmm.
Concerning your questions, why did I choose physics? Like, it wasn't physics at first. Like I started forming an idea about what I will do in the future when I was in high school. When I first started high school, at the beginning I was very interested in mathematics because of its consistency and self-sufficiency. Like, you could derive the whole mathematics using the ZFC axioms alone. And I found that very, very cool because I didn't experience this with other subjects that I was studying at the time. But in my last year at high school, I saw a very interesting application of mathematics in physical problems modeling. Like, for example, if you remember the circuits and the differential equations that we derive to explain what's going on in a circuit. Like, it was very basic, but it was very interesting. Like, how could we encapsulate the whole information of that system in a simple equation that links the changes in that system.
Yeah,
they found it so beautiful. Then, like, there were other reasons for my passion for physics. Like, I was reading a lot of books about science fiction and explanations of science, like distilled science. For example, Carl Sagan, Brian Greene, Isaac Asimov.
Okay, this was back in that time below في الليسي, c'est ça?
Yeah, I think 2015, 2016, that era.
Yeah.
And like those kind of subjects, like they were so fun. Like, I was having a braingasm, like meditating and on those ideas.
So it was your introduction to physics through pop science, let's say.
Exactly. Yeah. Somehow it was like an exposure to physics. Yeah. And then I decided, like, this is what I'm gonna do, man. Theoretical physics all the way. This stuff.
Yeah. Voila. I think most of us had that some kind of revelation. العام تاع الباك ديكوفرينا بلي فوالا I think I'm gonna do this. But it wasn't the case for me, unfortunately. كنت حاب ندير architecture because my father is an architect. بعد قلت at some point قلت no, I have also interest in mathematics and physics. قلت let's do this, why not? Let's try to to choose this. وكان عندي شويه هكا interest in renewable energies. كنت توجور نحوس نفهم كيفاش يمشيو. I think that's the case for most of الناس هما اللي نعرفوهم في الميليو تاعنا انا وياك بيلو، بتدخل الناس اللي خيروا فيزيكس دار كي كنا نقصروا كيف في لافاك ولا برا ولا في لاسيتي يونيفرسيتير. toujours everyone has some kind of a background story around this. So yeah. اوكي بيلو كي هضرنا كي قصرنا في البريفي، وداير كنا نهضروا هذا الصوالح بزاف كي نتلاقاو. كنا نهضروا على scientific theories، نهضروا على in theory كيفاش نفوندوها، كيفاش وي ناليمونتوها بالايدياز so we can make a whole كيفاش نقولوا a whole structure of ideas اللي يسمحوا لنا باش نابليكو هذا الثيوري. So how do you define a scientific theory?
Well, the most straightforward definition will be a scientific theory or the scientific method is the process of objectively establishing new facts.
Okay.
Like we have to debunk this statement for a second. Like the thing is like the scientific method deals with facts. It doesn't deal with values, for example, ethics or beauty, or like that's the job of axiology in philosophy. Like for instance, like we see a phenomena that we are interested in the observable world, and by curiosity we want to understand what's going on. We want to describe and like hopefully predict, because there are two models that we can create: descriptive models that explain how a certain phenomena is going on, and predictive models that predict the future of that phenomena. So what we do, like we first start by collecting data about that phenomena. Then like we process that data, like we use charts, we use different methods, mostly statistical methods, to process this data, and then using our intuition or dream or I don't know, or a leap of faith, because the process that happens in finding a hypothesis is different from one another. We make a hypothesis about what's going on. So the first part is done. After we have made a hypothesis, we start performing an experiment. To falsify our theory, because this is a canonical thing about scientific theories. Scientific theories, real science, needs to be falsifiable. In the definition of Karl Popper, like if there is, like for example, a theory like there is an interesting video on YouTube in the channel of Vsauce. It's called "Does the Past Exist?" During the whole video, like he tries to make you believe that the past didn't exist and it's only happening in your mind. Like whatever argument you will present to him, he will like twist his way into convincing you that the past didn't exist. This is an example of a theory which is not falsifiable, a hypothesis which is not falsifiable. This cannot be considered a real scientific theory. An example of this falsifiable theory will be the general relativity of Einstein. Like they were able to perform experiments to falsify this theory, but the experiments ended up proving it. Like statistically speaking, you are attempting to reject the null hypothesis. The null hypothesis is the general explanation or the general agreement on what's going on.
And when we say general agreement, what do you mean?
For example, let us take for instance physics. Newtonian mechanics used to explain how things interact and all.
Forces.
So the null hypothesis in this case would be, I might be wrong, would be like Newtonian mechanics are valid, or Newtonian physics are valid to explain ta or this.
This is the statement.
Exactly. And the alternative hypothesis would be something like, it will be the complementary of this statement, which is the opposite. Like, no, the Newtonian mechanics cannot explain everything, or something of that sort. And our goal here is to disprove the null hypothesis and indirectly or using the proof of contradiction, prove the alternative hypothesis.
Okay.
So in a nutshell, like in order to have a scientific theory, you have to make observations.
Yeah.
Make a hypothesis about your observations after you process the data.
Okay.
Experiment and test your hypothesis. If your hypothesis survives all the tests, then you have yourself a scientific theory.
Great. تسمى هكا عندنا method, عندنا steps that we have to follow باش يكون عندنا a scientific theory. This is what you are saying, Uncle. Back in the time, je sais pas نقولوا, let's say the time of Newton and stuff. Or let me rephrase. En fait, عندي another question. When in history, genre اللي حطينا هذا steps that we all, I think all scientists respect today, في les différents domaines اللي يخدموا فيهم. At what point of history we really حطينا les fondements هذو اللي كنت تهضر عليهم? If you have an idea, of course, about that.
Like my personal view, I would say that there is no demarcation line between the old thinking and the new thinking. It has been an accumulation of knowledge. Like, because when you take, for example, the emergence of philosophy in Greek, like people before thought. They used their mind. They thought, they created tools and all. But the difference between the old methods of thinking and the new methods of thinking were that the Greeks used arguments.
Indeed.
To support their claims, but before, like, it was just like speculations, mythology, and like they used all, like, religion also was a source of information.
True.
And like these mechanisms for acquiring knowledge and learning, like, they developed through history, they evolved, if I might say, and the methods accumulated. You see, till one day we got what we call now a scientific the scientific method, which can be improved more in the future. Like, it's not a constant change.
Exactly.
But like, if I have to answer your question somehow, like in a كيف يقولوا بطريقة متحفظة, I would say like the first emergence, the first recorded emergence of the scientific theory would be with Copernicus, I guess, because as far as I know, he was the first person to collect data, observe the data, analyze it, and make predictions which were kind of valid, like the context of what we know right now. Like, it was close.
True. Okay, I agree. En fait, سقسيتك هذا الكويشن because en fait لونسيت واحد لا سيري تاع episodes سميتها scientific tales. Je sais pas إذا شفتها ولا لا. When I'm trying زعما to highlight the important moments of science in history. Du coup مادام حكيت على the Greek civilization and philosophers, هذاك الوقت كانوا يعيطوا لهم the scientists were called natural philosophers. ومن بعد عاد جينا بالاسم تاع scientists بالك في النيو ايج تاع نيوتن and maybe before him بشويه. And what was interesting كي كنت ندير في لي ريسيرش نخدم في الابيزود and stuff, we find some ideas اللي كنت تحكي عليهم تاع الفوندمون تاع الثيوري. It begins with maybe some speculations, some observations in nature and stuff. بعد you دير لي فوندمون. And I think yes, it's هذاك التراكم تاع المعلومات and les méthodes اللي بدات وصلنا لورانا واصلين اليوم.
That's interesting, but because like the theme of the pre-Socratic philosophers of nature or natural philosophers as they are called, Thales of Malthus and I don't know, Anaximander and all of that. Like, the point that gathered them all under one category is that they seek the outside world. They were observing, they were trying to explain, and hence the name natural philosophers. Philosophy after them, like when Socrates and Plato and Aristotle, like they focused more inwards. See, the self, like they focused on values, how to be a good
Yeah.
person, how to be a knowledgeable person, and all of that. You see?
Yeah, true.
So yeah.
So McCain, we have two kinds of people, if we may say.
Yeah, like that movie. It was not me. It was Barry.
Exactly.
Yeah.
People that look to the outside and
It's like it's the introception and the extroception.
Exactly.
You are focusing outwards or inwards. Like you are constantly doing that. You are shifting between the two processes, and depends on which one you are focusing on more.
Okay, side question, Bello, side question. سؤال على الهامش هذا. If you lived في هذاك الوقت هذا pre-Socratics, what واش من فيلسوف تروح تتبعه ولا تحضر الدروس تاعو؟
I will be a slave, bro. I guess I will be a slave. I won't have that luxury.
I think, yeah.
But like seriously speaking, I was interested in نسيت اسمه Abikrat or something, like the first one who created the mechanism, like it was the first material philosopher.
Nice.
I think Thales, I'm not sure who was he. He was completely materialistic. I really like him.
Damn.
I really like that dude. Yeah. The name of the atom came from his description of the physical world. He said that. Yeah, he said as we divide the physical world, if you hold an object, a matter, and we keep dividing it.
Yeah.
At a certain point, we will arrive to an object which cannot be divided, and he called it atomos.
Atomos, indeed.
And hence the name atom that we use now, which is dividable.
Exactly, that's the problem. When also metallic quartz.
Yeah, like you know.
Yeah.
Like the scientific thinking did not go that far from the Greek thinking. Like they are still trying to answer the same questions, but using different methods and different tools, which is interesting to see.
I never thought of that. jamais خممت فيها بعد ما it's good, yeah. Outlining the good angle of view.
Yeah.
Okay. So bon حكينا على scientific method. سينا نعرفوها او موان مدينا شويه كونتكست هيستوريك اي هوب بيلو هاو تو كي كنا نقراو فيزيكس و اي ثينك جست عليها في فاكولتي فيزيك it was always about finding a correlation between the experiment enfin an agreement باش ما نقولوش correlation an agreement between the experiment and the theory. What was your first reaction كي لقيت كاش experiment تلصق مع theory في تيبي يقول لي.
I was happy. I was like, it was euphoria, like damn,
Eureka.
I predicted this.
Yeah,
I have knowledge.
كنت تطرافي لي جراف على بالي في البابي
ميليمتر. اسمك شو نطلع البوا هذاك ما قال لك اللي راه بس يجيو اوفر فيتد
to get the fit.
Yeah.
Okay. I think our third point would be the role of the scientific theory. Bellou, وش قصدك the role of the scientific theory? What is it? And to introduce our subject of the day, quantum physics. How is quantum physics founded as a theory? That's my question. Let's use it as if we can, of course, if you can, as an introduction.
So I will start first by the first part of your question, and I will. The importance of the scientific theory is that it gives us facts, as we previously stated. Like it doesn't deal with buts and maybes.
Okay.
It deals with facts, like, and the way to live is to live a rational life using facts, and it has improved. Like, I'm not denying that there are some negative aspects of it concerning how human used it and all, but like it's so beneficial, like to our existence and our self-preservation. Like for instance, the medical field, the applications in the medical fields of the scientific theory and all, and more specifically to physics, because I believe that the developments and improvements in physics induce other developments in other fields. For example, the creation of the semiconductors and the transistors made the creation of machines and like medical machines used in medical sciences possible. You see?
Yeah. Mm-hmm.
Like it by moving physics forward, we move all the fields forward because they base their work somehow on the scientific theories in physics. And like two of the most precise theories that exist now are general relativity and quantum mechanics. And let me explain what do I mean by precise.
Yeah.
I mean by precise like that, like as we stated earlier, we make a model, we make a theory which involves a mathematical model that predicts and describes the physical phenomena, and that model makes predictions, quantitative predictions. And like he says, if you do this and that, you will get this result. Mm-hmm. And we also have measurement devices for different stuff.
Okay.
Like for I don't know, for the wavelength or for the intensity of the sound or the heat or something of that sort. And then we compare those two results, the results that we arrive to theoretically and the results that we arrive to experimentally. Mm-hmm. And the quantum mechanics and general relativity give the most precise
results,
predictions till now. So the second part of your question, you said the importance of quantum mechanics or what?
No, it was
I forgot.
yeah, I know, because I take a longer question. But like the second part was how is quantum theory theory? Yeah.
How is quantum theory established, you mean?
Yeah, exactly. Yeah. How did we
okay
founded the thing?
Yeah, I get you. So like in the scientific method, from my abstraction, like you have several theories. Like we start with a theory. Mm-hmm. Then this theory has inconsistency. It has gaps of knowledge. It has things that it cannot explain.
داير بعدا راح نحكوا على الانكونسستنسيز هذه details
Then like scientists, like they study those things, those inconsistencies. They are very interesting because we will find a lot of results there. Like I don't know, like it's how do they say? It's a possibility for a new discovery.
Mm-hmm. I see.
In the classical theories, like there were inconsistency in classical field theories, like Maxwell's theory, equations of electromagnetism. And you have the Newton equations and laws for classical mechanics, and you have the statistical thermodynamics, the classical one. Like there were some gaps in those fields. For example, the symmetries. Like Maxwell equation, there were some Maxwell's equation. They didn't preserve some symmetries, and symmetries are very important in physics.
True,
they are very important. Like they didn't preserve symmetries under certain transformations, under Galilean transformation, which was a gap. Like the classical theories did not explain the big stuff and the small stuff, and we will focus on the small stuff because it's the topic of our talk now. For example, they did experiments on the atom, and they noticed that the orbits of the atom are discrete.
Indeed.
Which is something counterintuitive because we are used to actual classical properties being continuous.
True.
Like you don't say my phone will be here, then it will become here, and they don't know what happens in between.
True, yeah.
Like it's counterintuitive.
Yeah.
But they made those observations, and the classical theories did not explain this stuff. There was also the problem of the black body radiation, which was later on explained by I think Max Planck.
And it was Max Planck.
Yeah, he came up with the quantization of the energy. Black body radiation. There was also, I don't remember the quite problem, but I'm not very familiar with the history of science, to be honest. I just only know
the
fragments of the stories.
Yeah.
There is also the double slit experiment, which we studied in USTHB.
Yeah.
Like you throw like
electrons
and all, and you notice that there is a duality of nature
Yeah.
of these electrons. It's both a wave and an object, which is also contradictory because in some sense we can say that being an object and being a wave is a contradiction statement.
Exactly.
And through the laws of logic, we know that two statements which contradict themselves cannot be true at the same time. But we are observing them to be true. So
true.
What's wrong here?
Indeed,
what's going on?
I think بزاف scientists they call هاد l'expérience les fonds de Young en français. الناس اللي تسمع try to outline some keywords باش ديروا لي recherche تاعكم if you are doing them of course. Les fonds de Young هاد l'expérience بزاف scientists they call it the most beautiful science experiment because it's counterintuitive as Bellou explained. But at the same time it made me question بزاف صوالح دوك من بعد نرجعوا لهم كي نحكوا على inconsistencies and stuff and the intuitive and the unintuitive stuff but I will let you continue كمل
So like those inconsistency, like they made a lot of physicists focus on explaining this stuff parce que قاعدين les physiciens قاعدين كاين نحل ما نقولش كلمه واحده اخرى شغل كيشوفوا ورده اللي هي الجابس of knowledge يتلموا عليها كامل فاهم like the pioneers of quantum mechanics were there like Einstein also who opposed this theory like contributed to it a lot through his papers 905 papers for the big four. There is also Max Planck, there is Born, you have Heisenberg. I don't know if I mentioned Dirac or not Dirac, Schrödinger, John von Neumann, like all of these minds were focused on the sole purpose of understanding the atom. What's going on there?
For the clocks, I think they throw the hottest album in the science community, you know.
Yeah, it was like it was how did they say it was the I can't end the blog or
well, it's fine. Try to find this for later. So you're trying to explain that it's to كيفاش يقولوا كي تخمم في عبسه ولا you are willing to develop كاش عبسه maybe it is good to think about these gaps in the past theories and
like there is a paper by Steven Weinberg. It's called Big Four Questions or the Four Golden Lessons.
Okay.
Those four golden lessons are like this article. It's free on Nature if anyone want to read it. It was like a guide to future researchers on what topics to pursue and how to keep on going and all. And he mentioned that like you have to go there like when the dirty work is done. You see, like he was talking about himself. He said that a lot of people at his time like they were focusing on general relativity and all because it was easier somehow compared to quantum field theory. But like he didn't care. Like he went there like where the action is, and eventually he won a Nobel Prize for making the standard model with Abdus Salam and another guy which I forgot his name. Another scientist.
I think كما يقول لك to make an omelette you have to break the eggs actually.
yeah exactly.
Okay. Bellou, from your experience at least as a student of course and même كي ما تكونش تقرا ولا توجد لي زيكزامان ولا when you are reading books in your room ولا just scrolling in the net and stuff, how can someone do a good introduction ولا have a good introduction to quantum physics and quantum theory? وش لازم يقرا وش لازم يتفرج peut-être وش لازم يدير وش لازم
well like it depends on what background this person is coming from. So personally I have several resources that I use on my studies or my like personal reading for out of curiosity and all. Like you have first the simplest one of them is Quantum Mechanics by Griffiths.
Okay.
And you have the Bible in Algeria of quantum mechanics is Tanuji 1, 2 and 3. There are 3 tomes. You have Feynman's lectures on quantum mechanics, which is a lot of explanations but with no equations. I didn't like it honestly. It was not my cup of tea. You have also Quantum Mechanics by Albert Masaya. there is also the mathematical foundation of quantum mechanics by some guy called Bellou. It's Springer edition. There are a lot of books actually and a lot of resources online. You have, for example, a playlist, but it's somehow like it's advanced, using advanced mathematics into the formulation or the mathematical formulation of quantum mechanics. You have the lectures of Friedrich Schuller online. They are made for free. And I don't know. There is a playlist by Friedrich Schuller on quantum mechanics.
Okay, yeah.
It's very interesting and a very advanced topic. So, like, I think for an as an introduction, people should read Griffiths. Griffiths, it's simpler, and even the mathematics he uses, it's very simple.
Okay. So it really, كيفاش نقول, it really needs let's not say an excellent mathematical background, but at least يكون عندك bagage.
You will understand. You will get the main ideas of it. Because like the thing about physics, it needs a lot of an accumulation of knowledge. It's not very a hard field, but it needs it requires the person to know a lot of stuff as he reaches a certain level.
Yeah, I think it's sometimes كي نقرا هذوك لي زيستوار في scientific stories or something like that, ولا même كي تقرا article scientifique publié في كاش جورنال. And the person he uses مثلا البابي راهو على let's say thermodynamics, and suddenly he mentions at some point يحتاج let's say يحتاج اسمه يحتاج a theory ولا an equation اللي كاينه في pure mathematics ولا عبسه في الشيمي ولا راح جاب عبسه من دومين واحد اخر من دومين كاع واحد اخر وحطها, and you begin to question شغل السيد هذا عنده كاع الاطلاع هذا باش تقدر يبروستي على عبسه ديجا ديكوفراوها قبله ولا in parallel وجابها وقاعد ياليمونتي في الستادي تاعه, and it's amazing. I think it's an amazing.
Yeah, it's like the categorical the categorical discrimination that we created between fields of science, like medicine and physics and like electronics and all. It was just a reflection or a projection of our categorical thinking. Like, but there is no distinction between physics and medical science, because the photon, it will hit my eye and the eye will process the photon and all. It's all connected, but we use a reductionist approach into explaining phenomena and understanding them, because it makes them simpler and we can build upon that.
True, but still لازم we always have to have our war with the chemists. معلي شيميستي لازم.
Like, to be honest, I never understood this dialectic between this rivalry between chemists and physicists.
جامي دابس مع اسمه مع واحد يقرا شيمي.
Well, I think the reason why I don't do that because I'm more interested in quantum physics. Like, it makes me more close to them than to physicists. You see.
Okay, that's a statement. دوك يسمعوكم بعد أصدقاء الفيزياء ونشوفوا كيفاش نخرجوكم.
أنا صاحبكم ممكن أنا.
All right, great. Okay, Bellou, let's get back to the inconsistencies هذيك. I don't even know how to spell it right. The inconsistencies of classical theories. When we كنا بريباريو في الانترفيو هذا, I didn't really get it that much, so I would like زعما تبدلنا much details about these gaps in the theory, especially quantum physics مادام رانا فاتحين السوجي هذا, and let's try to build a discussion around it.
So the inconsistencies that I talked about, like, they were in classical models of the world. And like, we discovered that they are inconsistencies because we performed experiments that didn't go well with the models that we had at the time. Like, Newtonian mechanics could not predict like the levels of energy that an atom has. So these inconsistency and much more other inconsistencies, like, they pushed scientists into creating a new model to explain this new phenomena, and also be able to explain the old phenomena, because in the emergence of a new theory, you don't disprove the old theory because it's still valid in its context. You just make a more general theory, because quantum mechanics is more general than classical physics.
I see. Mm-hmm.
Actually, like when you think about it, like there is no classical mechanics, there is no classical world, it's all quantum world. And like classical world is just a special case of the quantum world. Like I will talk more about how quantum physics work, and also before we go in depth on that, like we have to make some definitions. For example, what do we mean by classical world? A classical world is a world where it's a deterministic world. Like you have a classical object. This classical object, let's assume I am having like this packet of cigarettes. This packet of cigarettes is a classical object. It has a deterministic nature. The values of its properties do not depend on its observer. Like whether I'm looking at this packet of cigarette or not, those properties will not change, and they will have a distinct value at each moment in time. You see, but like in quantum physics, quantum objects depend on the observer. Like before we do the measurements, we don't know anything about the state of the quantum object. It lives in what's called a trans-empirical state, because we cannot know what are the properties of that object. And the only means that we, like, after they created the model and all, we began to understand what's going on. Like you have a quantum object. The quantum object doesn't have a deterministic nature. It doesn't have a it's not objectively existing. Its existence depends on the observer. For example, there is that thought experiment. It's a philosophy experiment, but we can't draw the analogy here. If a tree falls in a jungle, and there is in a jungle, كيف يقولوا غابة، في غابة شجرة تحت في غابة وما كان حتى واحد يسمع. Would it make a sound or not?
Did it make a sound or not?
Would it make a sound or not? Like, but there is no one. There is no one around to hear it. Would it make a sound?
Of course.
But like sound, it's the sound is defined by us. If there is
بس ما كان حتى واحد يسمعها. Du coup, it's like it didn't happen then. That's the same time.
Like, it's the same thing in quantum mechanics. Like the act of us observing that quantum state or that quantum system
is the only
give it an objective existence, a deterministic existence.
Exactly.
You see, which is counterintuitive to the classical understanding of the world.
Indeed. تسمى حتى تشوف هذيك العبسه in the quantum world at least تobserve هذيك العبسه you give it its existence in this
and it's called the collapse of the wave function. And like so I think like صدمنا شويه كنا ديريكت.
elaborate كيما تبغي بيلو.
Donc the state is I just mentioned the state function. The state function is a representation, like it's postulated in quantum mechanics. The state function encodes all the information about the quantum system studied. So but we cannot access that information directly. The only means for us to access that information is through applying operators on that quantum state to get probabilities of us observing a quantum state in such state or another state.
Damn.
You see? It's weird.
It's counterintuitive.
It's very counterintuitive. And there is another postulate which is more disturbing, that the only probabilities that exist are the eigenvalues of that operator.
Les eigenvalues for the ones that
les valeurs propres. هذوك هما الوحيدين اللي قادر تقيسهم في experience. For example, in studying spin, les valeurs الوحيدين اللي راك قادر تقيسهم هو +1 ولا +1.5 ولا -1.5. de façon que راح نقول لك القهوه تاعي هذه تكون في فمي تكون محطوطه هنا برك ما عندهاش وراح تكون في بلاصه اخرى. بيزار.
شنو هذا؟
and it's كل حاجة it's stranger than fiction
True.
it's backed up with evidence 100 عام these experiences.
Yeah, there is je sais pas ما عرفتش اسكو فيزيسيان قال هاد العبسه ولا just someone ولا ما عرفتش وين جزت على هذا الكوت ولا somehow. المهم في معنى ما قال السيد ولا السيده التي قالت هذا الهضره، قال لك even thinking about it sometimes ما عندهاش معنى باسكو راك تسيي تيماجيني تفرض some kind of a picture، والايماجيناسيون تاع بنادم جينيرالي كي تفرض هذيك الايماجيناسيون ولا try to think about some picture some imagination you are forcément راك تبروجتي عبسه ديجا شايفها.
اكزاكتومون ميم الاخر بورن كي كان بدا كي قاعد يحكي على when he was trying to explain quantum mechanics,
yeah,
like he found a struggle because our language was constructed by our experience with the physical world.
True.
The classical world. We did not experience the subatomic world.
Yeah.
So every attempt will be to project those ideas into our physical or classical observed world.
Indeed, yeah.
Which will like make there will happen a loss of information in this process. It's like translating that abstraction.
True, yeah.
You see, like شو ترجم من الروسية لهذاك شو كاين واحد المعاني دي كومبورتمون كولتورال تاع الكلمات اللي راح يروحوا.
Yeah. Lost in translation, yeah.
For example, you have like there are some quantities in quantum mechanics that don't have a classical equivalent. Parce que le mécanique quantique plus générale classique. Par exemple, عندك spin.
Yeah.
واش هو السبين زعما تقول لي دور ماهوش الدور.
ما عندك ما تقدرش ما تتخيل.
You cannot. Yeah.
Yeah, it's a little bit weird وداير
fascinating.
Yeah, it's fascinating at the same time. We will talk about reality وكيفاش we perceive it from a quantum كيفاش يقولوا quantum perspective. But before that, let's speak about the emergence of quantum theory. I think هدرنا شويه على الايدياز من جاو، هدرنا بتتر على ماكس بلانك بيلو try to explain au moins les fondements, the beginnings. دونك اذا حبيتوا تشيرشي ولا I think بدات من 1900 وطلع هكا بيلو.
جو بونس الوقت هذاك 1900 وراح
1900 وروح. دونك الناس اللي تشارشي شويه في الهيستوري واللي حابين يفهموا واش صرا وكيفاش جاو there is many documentaries, there is many books, but Bello, what always العبسه اللي كتخلعني توجور، العبسه اللي كتخلعني وديرونجيني كي كنا نقراو في الال دو كوانتم فيزيكس and maybe because of that I didn't choose fundamental physics. زعما رحت في عبسه ابليكي، عبسه اللي نقدر نشوفها راك شي نقدر نتخيلها ونشوفها at the same time. So I remember this little story كان يقرا معايا كان البينوم تاعي ايوب شطوع، سي با اذا تعرفوا. anyways and he was great, he was a great student and I was trying to understand quantum physics. قلت دوكا من نبدا انايا دوكا كيفاش نطلع الموديول هذا راك فاهم. it was hard كذبش عليك. so قال لي لقيت واحد النهار رايح البيبليوتيك. so I said this is my chance, I need to follow him, maybe I will get some recommendations about a book or two. so دخلنا البيبليوتيك. السيد راح يجبد كتاب تاع ديراك وكوانتم فيزيكس. انا نقول لك الانتروديكسيون ما تقريبا ما كاينش انتروديكسيون ديريكت فورميلاسيون ماتيماتيك. and what bring me to this سيكو سيت نقرا في هذاك الكتاب وما قدرتش، جاتني صعيبه لا فورميلاسيون ماتيماتيك. so I wanted to ask you the mathematical formulation of quantum physics below. Did we have to really invent a new thing or we based it on صوالح كنا
No, we did create a lot of new things and like in the context of what you are saying في الأرض ما طلعتهاش زيد طلعتها بديس
we all been there bro.
في الماستر ما طلعتهاش في السمستر الثاني دونك yeah like but like I know that they created new mathematics for it. But I don't quite understand it, to be honest. بس زعما شغل they created spectral theory in mathematics. You have Banach spaces, Hilbert spaces, functional analysis, measure theory. Like those mathematical, these all mathematical attempts to explain this new phenomenon observed on the world, because as I said earlier, like the one of the a lot of interesting stuff in quantum mechanics is that it gives discrete values. For example, the energy is discrete.
Okay.
And we had to create a measure theory that takes in account this nature of mathematics of quantum mechanics. I think the first guys who wrote on quantum mechanics were Dirac, as you mentioned. He wrote a book about the foundations of quantum mechanics.
Yeah, I
and
think
there is Jean von Neumann. He wrote the mathematical foundations of quantum physics. Quantum theory, I think. I don't quite remember the name of the book, but Jean von Neumann, quantum something, you will find the book.
Yeah.
And it's like at the beginning there were two kind of models for quantum physics. There was Heisenberg matrix mechanics, which based its functionality on the assumption that wave function or the state function of the quantum system was static in time, and the operators that are the means to extract information from the wave function were variable through time. But like the Schrödinger approach was the opposite. It considered the operators to be static in time, but the wave function to be developing through time. And like we could follow this process or the temporal changes in the dynamical and cinematic changes of the wave function by means of the Schrödinger's equation, the famous Schrödinger's equation.
Yeah, I think it's la formulation mathématique تاع quantum physics. It's a weird thing. They had to invent بزاف ماشي invent, let's say.
I would say invent because I think mathematics is constructed. It doesn't. It's a language.
Yeah, they had to invent like a new mathematics. ومن بعد تريح انت في الشومبرا تاعك فلاسيتي trying to understand this this thing.
Yeah, I get you. And that's what I'll do. Like I spent a lot of time trying to trying to understand the derivation of Schrödinger's equation. Because as I told you in the beginning, I was a mathematician at heart. I was my first love was mathematics. So I was very fascinated about the proofs and all. Like, this is how I understand stuff through their derivation. Like I spent a lot of time looking for the proof of Schrödinger's equation. But there is no proof for it.
There is no proof.
There is no proof.
اكتبها سي.
شغل اللي يجيبك واحد انت مثلا في عمرك 5 سنين ما تعرفش تعوم ويطيشك فروشيات. هكاك بعد داروا لنا.
Yeah, it was like that. Je sais pas. Do you think سؤال هامشي هذا على السيستم التعليمي الجزائري في مجال الفيزياء. Do you think we need to change something? سيرتو في ال2 the introduction to physics. شغل الكف هذا كيفاش نديوه. We need to make it gentle.
with more prerequisites. باسكو حنا البوافا اللي صرات لنا حنايا اللي روماركيت انا بيتيت راني غلط باسكو مانيش اكسبير انا في التعليم في كاع هذوك. مي انا روماركيت انه ما بازاوش بزاف على ستاتيستيك باسكو بعد الميكانيك كونتيك كاين بزاف ستاتيستيك باسكو راهي ستاتيستيك و probability لا ماجوريتي دي تو you have to connect all the stuff together. حنا كشغل ما يمكن نقراو لي موديل راه كومبليمونتير فاهم هو بروغرام مليح هاي مي كشغل ما كانش اللي يربط لك بين لي سوجي. انت قريت لي زانتيغراليتو ومن بعد قريت ما بينش لي زيكواسيون ديفيرونسيال ومن بعد قريت البروبابيليتي وهكا من بعد قريت ميكانيك كلاسيك وقريت لي زيكواسيون ديفيرونسيال اللي عاودتها قريت الاخرى لاناليز ما باليش كومبلكس. مي هاد لي سوجي كامل انت ما تربطهمش باش تقول بلي لازم نفهم هذه هكا معايا شغل عندك
it's unfortunate somehow عندك كاع لي زوتي اذا فريمون قريت وحطيت راسك وكنت تتبع عن ستوب بصح كي تجي تابليكي it's hard but what triggers me the most وما كي كنت نقرا ثم في الفاكولتي and stuff وبالك ما مدركها is the physical interpretation Bellou. Do you think language is sufficient, our current language is sufficient to describe quantum physics results?
Well, I will just say my humble opinion. I don't know مش بيقولوش سيدو قاعد
Oh.
the way
Yeah,
I see it that like language is just a means to model the world. I think that the world in itself it's so much different than our model parce que sur mécanique quantique et relativity like they are just models that work based on our thinking on our experience of the world to understand the world, but the world in itself you cannot view it like I think there is a saying for born or bored. He says that the world is not statistical, human thinking is statistical.
Damn.
You see? So somehow like we are شغل كي تخمم فيها like in most of the fields other than hard science fields.
Yeah.
Humans used to study nature and ethics and philosophy independent of themselves of themselves. But now in the contemporary era we are taking in consideration our actions in observing the world and
meaning
like شغل بكري ما كناش نهزو en considération l'interaction تاعنا مع لي سيستم.
D'accord.
باسكو شغل بكري كنا نحسبوا روحنا رانا انديبوندون على لو موند.
Yeah.
ميم لي زانتراكسيون تاعنا مش راح ياثروا بزاف. Like for example in quantum physics and all like the slightest perturbation in the system will change the state.
Yeah.
So
true.
Somehow this is the
revolution.
Like the models are just a reflection of our understanding and all. And like for example when we talk about quantum mechanics that we all agree that it gives correct results and valid results that go along with experiments. But here comes the human interpretation. Like different schools interpreted what's going on differently. For example, if you take the classical world, you can describe the movement of an object using Newton's equations, the Hamiltonian mechanics, or the Lagrangian mechanics, Hamiltonian and Jacobian mechanics. It depends on your specific problem or the context you're working on. The same thing happened with quantum mechanics. It had different interpretations. Like you have, like there are several, I will mention a few. Like you have, for example, the Copenhagen interpretation, which is the widely accepted interpretation. You have the deterministic interpretation, which is its founder is Einstein. And like you have the agnostic interpretation, which says I don't know, I just calculate and they shut up.
I think كان لقيت واحد الكوت قرديته تاع اينشتاين. He says reality is merely an illusion, albeit a very persistent one. Do you agree with this?
Can you repeat please? Like I didn't understand it very well.
Okay. Einstein said reality is merely an illusion. La réalité is merely une illusion tout simplement, albeit a very persistent one. Although
that's interesting. That's very interesting coming from him.
Yeah, exactly.
And like شغل بعدش بزاف نشوف هاد talks يقول لك like reality is a hallucination that we all agreed on.
Yo.
You see? Yeah, it's weird, but because like if you want to go in depth in this, like the only means of communication between me and you is the natural languages, like either English, Shawiya, or Arabic, or French, or whatever language that you are using as a means of communication now. But like you cannot enter my perception of the world and confirm your version of reality. You just have to take my word for it. You see? Like even like you know, like there is in the human eyes. There are certain neurons that see certain colors. I don't quite remember the colors. I think red, green, and blue. Like they did an experiment and they brought the same red color with the same wavelength and they exposed it to different people. They had the same neurons. But each one of them described it to be with different intensity. So there is something different going on there, but statistically we agree on the average on how things are going.
The mean is there.
Like we are agreeing to how the matrix is functioning. So. We are agents.
And and the glitches, we have to study them, I think.
Yeah.
هذه إدريس يموت عليها يقول لك there is a glitch in the matrix. So yeah, I think the next point that we will talk about is the applications of quantum theory, because تلاقى بعيبات في حياتك.
احكيوا عليها يا اخو.
فوالا يقول لك
We talk about it.
You know.
This is the application of it. We meditate.
يقول لك انتوما لي فيزيسيان تقراو وتندبوا منها بصح من بعد علم الغبار هذا
بعد نروحوا نقريو في السيام. But seriously, like it had a variety of applications. For example, the transistor, understanding the application of quantum mechanics in solid state physics. It gave birth to the transistors.
Yeah, it was Feynman's works, I guess.
The transistor, no, I think Shockley. It's a scientist called Shockley who took the Nobel Prize with two other dudes on creating the first transistor, or observing the Shockley effect, or something of that sort. Like they created the transistor, which is the basic component of computers and the phones and every technology that we are enjoying now. You have also, it's based on the semiconductors and the bond theories on quantum mechanics, and you have also like superconductors, like which is not applied right now, but like there are researchers on it, like improvements of primary materials that we create. That we create tools with, like machines and screens. You have also laser, which is applied in a variety of fields. For example, you use lasers accompanied with an understanding of the to detect stuff, like with
ultrasonic stuff,
ultrasonic technologies, or
detection, even
using detection, and using in the medical field, using lasers in the medical field, like
I think most of measurements in modern physics they use laser, at least على بالي في الدومين تاع ميكانيك دي فلويد. For example, كي نحبوا ندرسوا في الويد يكون يتحرك, we put some small grains in it. لازم تكون special matter that reflects light. ومن بعد نحطوا اللازر يضرب فيهم.
Because lasers don't interact with the system that much. It's negligible.
Indeed. But
there are a variety of applications, like, but the most promising one, like that I am personally interested in, is the creating the quantum computer. It's a cliche, quantum computer and all, but it's very interesting if we see it in action, because this achievement will enable us to decrypt the strongest crypto systems that exist right now, like the RSA or the iOS.
I had on Bellou, I had my small introduction to quantum cryptography, because I have an uncle اللي سنان انفورماتيسيان اللي يخدم عليهم. Maybe إن شاء الله نجيبه في interview. He will talk about this stuff. So this is what interests you the most in, I think, in the applications?
No, not really. Like I like quantum physics in the how do they say, like in statistical quantum physics is okay. I appreciate them the most, to be honest.
I see. So next year or this year, Bellou, راح تكون master 2, c'est ça? In quantum in fundamental physics, theoretical physics. Do you think that you will work on quantum physics as a subject?
Probably, like if I found the subject. To be honest, like my goal is to work in an intersection between quantum physics and deep learning.
I see. And
so this is my goal, my aim, if it happens. Maybe if not, like I am interested also in solid state physics and like, but
other subjects,
quantum approach in to solid state physics.
What's the relation, Bellou, between the quantum physics and the deep learning?
like there is no relation that I directly can see.
Yeah.
Like I'm interested in somehow like probably making predictions about quantum systems using deep learning. Like I don't know.
It would be really
It's
interesting.
interesting. Yeah, exactly. That's,
I can imagine the calculations in it.
yeah, I think I read some papers that like they calculated
Mm-hmm.
some properties of some materials using deep learning networks.
Mm-hmm. I see.
Which gave a good results, I guess.
Okay.
So it's a promising field, I think.
Great. I think we covered the applications of quantum physics parts, at least somehow. داير الناس اللي بغوا يشيرشيو that you have internet, just to use it well and you will find many applications. Unfortunately we can't talk about all things for an interview, but yeah, I hope we give you the keywords. Below, let's jump to the interpretations. I remember كي كنا نقراو physics ولا quantum physics في ال 2 at least واحدة من les interpretations اللي كانت تعجبني is the Schrödinger equations interpretations and results when we solve them for specific cases, of course, and stuff. And I think I did some reading منها you know, pop science we have YouTube half-baked opinions, you know, to get half-baked opinions.
Yeah.
And there was this interpretation about the things happening simultaneously. راك شايف صوالح يصراو simultaneously, and I think كي كنا نديروا نحلوا لي زيكواسيون كنا نلقاو لي زيتا سوبربوزي اذا تشفى. So there was some interpretations اللي يقول لك مادام صوالح يصراو simultaneously but they are happening in different universes. So what do you think about this crazy idea of parallel universes, different universes?
The thing is, like it's called the Copenhagen interpretation. Like,
okay,
I think that idea is taking the Copenhagen interpretation a bit too far. It says that the quantum state before it's being observed, like when it is in a trans-empirical state, it occupies all possibilities. It exists in all the probability space at all states at the same time.
Okay.
Which is counterintuitive, as we said, but this is not an intuitive theory, so we will stop mention that it's counterintuitive.
Yeah.
Like, and there is actually a novel my friend Ahmed introduced me to the other day. It's called I think Dark Matter. I don't remember the writer, but it speaks about a guy who was making a machine that isolates the person. It's like a superposition machine for classical objects.
Okay.
And like you have to inject a certain serum on your in your body.
Okay.
Then you enter that machine, you activate it, and you become in a superposition state. Like,
damn,
you become able to do things that you didn't do. You see, Zama, you superposition, and you create new worlds.
New worlds, yeah.
New realities. It's very interesting. I will not spoil for the listeners. You have to check it out. But I said it was widely accepted that the Copenhagen interpretation is true and it reflects the nature of reality. Yeah. But there was some like people like Einstein, like they disagreed on this interpretation and called quantum theory to be an incomplete theory. Like he argued that there are some hidden variables that were not taken in account because it was deterministic. It didn't make sense because, as I mentioned earlier, like quantum mechanics only gives us probabilities, and the probabilities, like this is not a classical probability due to our lack of information or about the initial conditions of the system. Yeah, it's intrinsic to the quantum state. It's probabilistic. Like if you only have one quantum object, you will only have the probability.
True.
Was one of its properties. But like in classical statistics, for example, what makes us go to and use statistics because we have a big system with a lot of objects that are that let's suppose for the sake of simplicity that they are independent, and we don't know, like for example a classical gas, like we don't know the initial conditions for everything. Like we cannot, and the equations created are a lot, so we have to take a statistical approach to this problem using the statistical principles like the law of large numbers and
Mm-hmm.
and whatnot. So Einstein here, like he said, no, like nature is not intrinsically probabilistic. This could not be.
Mm-hmm.
And he started the debate after, like with Born. It lasted till his death. It started in the Solvay meeting, physicists meeting, or
Yeah.
named something like that. And like he started a bunch of thought experiments to disprove quantum theory and to show that it's not consistent and it's an incomplete theory.
Yeah.
But later on, Born replied to every inquiry he had, and Einstein unfortunately lost the debate.
lost the war with him.
Yeah, he lost the war.
Yeah, I guess it's les interprétations هذو they are intriguing but they, I think they are great. They are great imagination material. داير شفنا les applications تاعهم في sci-fi movies like Marvel and stuff.
Doctor Strange and the Multiverse.
Indeed, Doctor Strange in the Multiverse. I remember كان واحد لا سيري شابة كانوا يجيبوها في NBC Action. The main theory is parallel universes basically, and you have this crazy scientist and his son and another investigator معهم تاع FBI.
I think I guess our
French.
Our tendency to go further steps in those interpretations and project them to our lives, it's somehow related to a deep buried desire of us to change the past, to live new lives. You see, so because زعما لو كنجيبو for example the general theory of relativity or special theory of relativity, we know that the time moves slow when objects are speeding, but like the time dilation, it cannot be observed on big objects like us humans or planes, or it only can be observed on particles which have very very small you see, which is actual in science fiction. He says we will travel like in Star Wars, and we will travel at the speed of light and blah blah blah. But we don't take in consideration that if someone reaches 50% ما باليش هذا مش من برسنتاج من لا فيتاس د لوميير واحد يتكعبر
يدخل في بعضها
مش بارتيكول. You see, I think that actual this kind of interpretation they are cool to meditate upon. Like imagination is great. Einstein says logic will take you from A to B, but imagination will take you everywhere. But like just keep it there, keep it like in the imagination realm. It's good to see it, but
sometimes it's really overwhelming.
I think it has been used a lot. Like I don't know.
True. Most of sci-fi movies they are basing. I'm very the only movie that gave me that it's فيها some scientific stuff, but maybe Interstellar, because she تشوف behind the scenes and the making of the movies جابوا دي فيزيسيان جابوا عباد يخدموا على فريمون على لا سيميلاسيون تاع black holes and stuff. Just for the visualizations and stuff, of course.
It's like it's interesting to see it like this way, like to see science and physics in particular change in how we view the world or something. Like in our talk earlier we talked about language, but there is a point, there is an interesting point, like the science didn't affect our language yet. You see, parce que we are still using up and down, we are still using, I don't know, some kind of words which are inconsistent with how science is working.
True.
So I think those attempts of like making science public to the available to the public, it's a good attempt that it will improve and enrich science. Like there is like quantum physics, it was mentioned in Ant-Man.
True, in Ant-Man.
Quantum realm, but they just said quantum realm.
I was in the quantum realm for years actually. For him it was 1 hour or something like that. It's interesting زعما to ترد la science هكا you give access to the public, but at the same time كاين عباد اللي يديروا لا vulgarisation scientifique, they may fall in some false interpretations and stuff.
It has to be rigorous at some
Indeed.
point. Because, like as I mentioned earlier, my beginnings were with science, pop science stuff. But later on, like it became more rigorous as I followed like there is a website for people who are interested in pursuing physics and studying physics on their own. It's created by a guy called Hofted or something. It's called How to Be a Good Theoretical Physicist.
Nice.
You will have a step-by-step guide into being a good theoretical physicist in his.
That's I think that's great. Speaking of that, Bellou, if you can give some recommendations on YouTube channels and sites that you in pop science and other stuff, if you
well, like I personally enjoyed watching Carl Sagan's show Cosmos as I was growing up. There is also I don't know. I used to follow a lot of pop science channels, but I don't remember them, to be honest. So currently, I'm just following university open courses, like for example MIT and ICTP. ICTP is very good in the lessons that they make available to the public. There is also the lectures of Friedrich Schuller that I mentioned earlier. They are very, very interesting. There are a lot of variety of articles online. Like just you have to learn how to search on Google. Like I don't know, write the topic you are interested about and type down sit edu to get good results. I don't know. And don't use Z Library and Library Genesis to download the books illegally. And don't use Science Hub to download articles illegally. That's not good. Do not.
فضحتني because I'm using all what you mentioned بصح معليش even for my research and for my but okay
it was a low-key invitation, bro.
Exactly. if you get the message راكم سمعتوا Bellou. Anyways, so I think the next point is okay, we spoke about quantum theory, how it's beautiful and stuff, but I have two questions. The first question is physics boring? And the second question is, what are the limitations of quantum physics? برا la limite.
Is physics boring? It depends on the person. Personally, I don't find it boring. I find it enjoyable as hell. Like it's so fun, like understanding those concepts and like I think like if you compare me at the first time I started learning about physics and now, like it really helped me improve my way of thinking. Like those tools I used in studying different phenomena now are integrated in my mind. I do them subconsciously, like the process of reducing a problem to a simpler problem, then solving that problem, then building on that problem. It became a cardinal part of my patterns of thinking. So most of the time I find it very fun, like, and it's not like only applied to physics. Like you can use the methods used in physics in other fields. Like you have, like you can use it in economics, you can use it in, I don't know, in data analysis and all. True. You can use it in several fields because it's a general knowledge that you can adapt, like especially the modelization part of phenomena. Like you can model any phenomena you will encounter in your professional life or your career, or whether you are pursuing an academic career. I don't know, you want to change research. Like the other day in Lulbara, I was listening. Lulbara. I was listening to a channel, channel in, I don't know if I can channel for Clubhouse, which I don't know. Room. I was in a room. I was in a room. And there was a researcher who was doing his research on biology.
Okay.
With a background in physics.
Nice.
He was studying learning like how molecular systems learn and stuff. Even Schrödinger changed the field later on. He became a biologist. Like,
I didn't know that.
Physics.
I didn't know that.
He was very interested in biology.
Nice.
Yeah, he mentioned that in his Mind and Matter book. And he wrote also about biology. So like the knowledge you will gain from studying physics, you will apply it to other fields. But Now we have to be realistic so we don't mislead people.
Yeah.
If you need another source of money, bro.
True.
You need really another source of money because especially if you are going to continue your studies here in Algeria, because you won't be able to finance your research or your life.
True, yeah.
So if you have a good monetary background, and you are interested in it, just go for it.
Yeah,
but if you are
that.
from a low or a middle class person, you have to take a lot of stuff in consideration and know what are you going to risk and know the risk and benefits. Concerning your second part of your question, نسيته يا صاحبي. حكيت بزاف
يا داير دوك بالك في at the end of the podcast نرجعوا لهذا like I نسيتها لك تاع physics and stuff. Maybe we can give some advices to the people اللي ان شاء الله راح يعطوهم الريزلت تاع البايك and stuff. Congratulations deja from now. Run my friend. No, for reals. We will try. Let's try that at the end. My second question was, what are the limitations of the quantum theory?
Well, like there is the limitations of quantum theory is that it only explains the small stuff. Like there are مانيش حاب نكون زعما مانيش حاب نغلط العباد.
Yeah.
I want to be more I want to articulate my idea better. So there is an inconsistency between quantum theory and general relativity. Like because general relativity explains big stuff, how big stuff interact with each other, and dense stuff.
Yeah.
Like when the density is big, like quantum mechanics fails to explain what's going on. And there is somehow an كيف يقولوا المهم يمشي مع بعضهم. You see, and the goal now is to find a unified theory that both explains the macroscopic world. أنا نشوفه في العالم العياني والكبير and the microscopic world. And like it's very hard to achieve that because you will need two conditions. You will need very dense objects and very small objects. And perform experiments on that.
Okay.
Where do we find this kind of objects? In black holes.
And you can experiment on a black hole.
Yeah, but that's the thing. That's the limitation. Like there are some hypotheses, but they are called theories, but they are still hypotheses. Like for example, the superstring theory and the quantum loop theory, which aim to unite these two theories together to form
the theory of everything. So
it's like the problem to articulate it in a better sentence. Like the problem of quantum mechanics is that it cannot quantify gravity. It didn't quantify gravity yet.
I think it's I think واحد نهار واحد سيد قال لي everybody is a gangster until the quantum physics hits actually.
like شغل earlier قلت لك باللي زعما scientific theories emerge from gaps. And those gaps are created like they are noticed through inconsistencies. Like Maxwell equations came from like the inconsistency between Faraday, electricity, and the magnetism. He unified the two fields. And then came Newton, like he unified cinematics and dynamics. And created the mathematical formulation for that. Then came Einstein, who united them like the Maxwell equations and the Newtonian mechanics. The general relativity. You see, how can I contact واحدة?
واحدة. It was born. You see. It's
جات هكاك دايركت بالسما هكاك واجدة.
True. It's a beautiful ugly child actually. The 90.
The thing is that like physics is an attempt to unify theories, and like when we arrive to grand unified theory that explains everything. It will explain everything physical in the context of physics. Parce que everything هذيك كابل لعبة ديال تريبليتيوها أنا قادرة تكسبليكي لك ليكونومي or something. Yeah, so it explains. That's the goal. That's the ultimate goal. زعما actual ترى تسقسي واحد واش راك دير هناك يقول لك هو قادر ما يجاوبكش بس هو داخل
يهرب.
to unify
quantum physics and
quantum physics and general relativity.
Yeah, I guess there is a lot of shit posting groups on Facebook واسمهم Grand Unified shit posting, I guess. Yeah, تلقى فيهم هكا crazy news about.
Maybe actual physics modeling will become memes now. We will stop using mathematics. Like they are using Feynman diagrams in quantum field theory, so probably in the future we'll use memes. Who knows?
Yeah, who knows? But everything is possible مع هاد العجب هذا. Okay, I think we covered the statistical part of quantum physics. I don't know, maybe not in a deep way. So Bellou, what are your informations ولا صراحة اللي تعرفهم على statistics as mean to understand quantum physics? Did you encounter that? Did you?
Like statistics, like there is the statistical interpretation of quantum mechanics, which was suggested by Born. So at first, like the Schrödinger equation did not explain what is the wave function and all. So Born suggested that the wave function will give us the probability of existence of the quantum system in a certain state. So like we used tools in statistics, applying them to the mathematical modeling of quantum mechanics to get probabilistic results. For example, you will get a probability of getting the system in a state A, like 16%, and you will find the rest of the percentage in a state B, like something like this. I don't know if I articulated it good or not. Like
I guess we covered the main axis that we wanted to talk about. I think رانا في ساعة و20 دقيقة ديجا. It's interesting. هضرنا فما. So I hope الناس اللي سمعت got the main part of what Bellou tried to explain today, and we thank you for that. It was really amazing to talk about this subject. So at the end باش نختموا Bellou, what are your advices to people اللي حابين يقراوا physics, particularly they are interested in quantum physics? بتتر هضرنا شوية عليها قبيلة, we promise to elaborate at the end of the interview. And to you, in your opinion, how do you see the future world in general? At least في بلادنا في الجزائر. How do you see الuniversity Algerian, الناس اللي تقرا, الناس اللي تخرج, and voilà, give us your perspective.
So the advice would be just like work hard and solve a lot of problems. Like you have to solve a lot of problems to gain a background, because when you are facing a new problem, you will have to link it to an old problem that you already solved, and you base your solution to this new problem based on that, and you elaborate and add some details specific to this kind of problem you are solving. And just like you have to be sure about where you are going. Like you have to make a 5 years plan on what's the ultimate goal for you in those 5 years, and just work hard on it till you reach it. The way how I see the world in the future, but I think that probably artificial general intelligence will be achieved. Like, and we will have robots which are conscious and can pass the Turing test. Maybe, I don't know. Like I'm kind of optimistic, but like the healthy amount. I'm optimistic in a healthy amount about the future. I think that life will become much easier because most of the tasks will be automated by means of artificial intelligence, machine learning, and deep learning. Techniques applied to the machines and all. hopefully they will create what's called basic universal salary, because like by automating every most of the tasks, like people will not find labor, like so
that's the problem.
yeah. So in Algeria, I don't know. Algeria ما نعرف. مانيش ما عنديش موديل بريديكتيف، عندي موديل ديسكريبتيف برك ما نقدرش نقول.
Yeah, you know, we are, I think, رانا في الهبطة and to do
رانا في إيطاتا سوبربوزيسيون، رانا
زعما
ترانس امبيريكال ستيت ما نقدرش نعرف حتى نشوفه.
Yeah, indeed. Yeah, let's hope for the best in every aspect of our lives. Class, I think this.
Yeah, that's it. Like you have to be hopeful about the future. So
indeed, and pragmatic at the same time. So make the right choices, people.
Yeah, make the right choices and be kind to each other. You don't have to forget that. Yeah. So
Bellou, this was so fun. I enjoyed every idea we discussed. يعطيك الصحة. So any last words?
Well, thank you for this amazing opportunity. I was so happy to share those ideas with you and all. Like I always enjoy talking to you. ممكن كنا زعما في لاسيتي نقصر كلش زعما.
Same for me.
Yeah, it's really cool. مشكل شغل ما فيش قدرت نحكي له شي كم دايركت.
بزاف من بعد دايركت.
بزاف. So I'm really glad about this experience, and I thank you again for hosting me and being such a good conversator or conversation. I don't know كيف يقولوا محاور جيد.
Animator.
Animator. Yeah.
Thank you again. It was my pleasure, and I hope we see you in other episodes of Scientific Hadra. So الناس اللي كانوا يسمعوا فينا يعطيكم الصحة إذا وصلتوا إلى هذه الدقيقة من الانترفيو. It means you are really interested and you are really listening. So keep it up. تهلاو في رواحكم, and we wish you more self-esteem to the point you become humble. نلتقي في حلقة واحدة أخرى في انترفيو واحد آخر بوتيتر. وتهلاو. Still